Hey, welcome. So today, we are diving into the different branches of data science. But look, instead of just giving you a boring list of definitions, we're going to see how all these different roles actually work together to solve a huge life or death problem. Let's jump right in.
All right, picture this. There's a mysterious illness ripping through a city. Panic is setting in. Hospitals are getting totally overwhelmed. To stop something like this, you don't just need doctors, you need data. But with all that chaos, where in the world do you even begin?
Well, before you can find any answers, you've got to deal with the mess. You've got information flying in from literally everywhere. It's disorganized, it's disconnected, it's just a lot. And this is where our first specialists come in, who I like to call the first responders of the data world. So, meet the data engineers. You can think of them as the architects and, maybe more importantly, the plumbers of the data world. Their job isn't to find the clues themselves, not yet. Their job is to build the solid, reliable foundation that everyone else is going to depend on. Seriously, without them, nothing else can happen. So, what's their first move? It's absolutely critical. They take all those chaotic sources, we're talking hospital records, lab results, even public transport logs, and they pull them all into one central place. They build these reliable data pipelines so that new information is flowing in constantly, in real time. And maybe most importantly, they clean it all up. They turn that absolute mess into a single, trustworthy source of truth.
Okay, so the foundation is built. We have clean, organized data. Now the investigation can really begin. We're officially on the hunt for clues.
And for that, we need our detectives, the data analysts. These are the folks who really get their hands dirty, you know? They're sifting through all the evidence, looking for anything that stands out. They take that pristine data from the engineers and they start asking some really smart questions.
And they find things fast. All of a sudden, these raw numbers, they start to tell a story. They see that case clusters are popping up near the city port. They figure out that symptoms usually appear about 48 hours after someone's exposed, and they even nail down a high-risk age group. And just as important, they start ruling things out, like it's probably not the water supply. These are our first real, solid leads.
But here's the thing. An analyst is great at finding answers to specific questions. But what about the clues you don't even know you should be looking for? Well, that's where data mining comes in. Think of it like a superpowered detective that uses algorithms to automatically search for these hidden patterns that a human eye might just completely miss.
And boom, this is where data mining just completely shines. It uncovers this shocking connection that was not obvious at all. A huge majority of the early cases, we're talking 85%, all used the exact same subway line during that morning rush hour. Now, this isn't just a clue, right? This is a potential breakthrough.
Okay, finding the source is one thing, but with a virus, you have to know where it's going next. You have to get ahead of it. And that means we need to shift gears from just analyzing the past to actually predicting the future.
To do that, we got to move beyond just finding patterns and start measuring our confidence in them. I mean, how sure are we about this subway link? Is it just a crazy coincidence, or is it a critical piece of this puzzle? Well, that is the job of statistics and probability. It is the hardcore science that gives us the mathematical backbone to quantify all that uncertainty, helping us tell the difference between a real signal and just random noise.
So the crucial point here is how new evidence completely changes our thinking. It's a concept that's beautifully captured by something called Bayes' theorem. You know, before that data mining discovery, we might have thought, the subway link is a long shot. But after analyzing that transit data, our belief totally updates. The probability just skyrockets. We're now highly confident we found a major way this thing is spreading.
So now, let's turn this confidence into an actual forecast. For this, we bring in the futurists, the machine learning engineers. What they do is build these amazing models that learn from all the data we've gathered, the demographics, locations, those transit patterns, to predict where the illness is going to surge next. And it does this with minimal human guidance.
And this is what that actually looks like in practice. The machine learning model doesn't just give some vague warning. No, it provides a prioritized, actionable list. It tells public health officials exactly where they need to focus their limited resources. Neighborhood A is the highest risk, then B, then C. This is predictive power in action.
Okay, so we've got the foundation, we've got the clues, we've got the forecast. But all of this amazing work is pretty much useless if the people who have to make the decisions, the mayors, the health officials, can't understand it.
We have to bridge that gap between all this complex data and a simple decision.
This is the world of business intelligence, or BI. The BI specialist is the ultimate communicator, the storyteller. They take all the complex charts, the dense statistics, the predictive models, and they transform them into these clear, concise dashboards and reports that a non-expert can understand in an instant.
You know, this quote from Carly Fiorina just sums up the entire process perfectly. The data engineer gave us raw data, the analyst turned it into information, and now BI is turning that information into the insight needed to make a critical, life-saving decision.
So let's just quickly recap that whole journey. It started with data engineering, creating order from total chaos. Then, data analysis found those first crucial clues. Machine learning then predicted the future. And finally, business intelligence delivered a clear, simple plan. Every single step was essential, and each role built directly on the last one. It's a team sport.
Now, this whole process isn't just about some fictional outbreak, right? It's really a blueprint for how we can start to tackle some of the world's most complex problems.
And this right here is the ultimate takeaway. Data science and all its different amazing branches gives us this incredibly powerful toolkit. It is a systematic way to turn the chaos of the real world into clarity, and then to turn that clarity into decisive and often life-saving action.
And that really just leaves us with a final thought to chew on. If this structured approach can help us stop a virus, just imagine its potential everywhere else. What could this exact same collaborative process do for understanding something like mental health trends, or improving nutrition, or managing chronic diseases? The possibilities are they're vast.
If you found this breakdown helpful, please be sure to like and subscribe for more. And I'd really love to hear from you. What complex topic should we break down together next? Let me know down in the comments. Thanks so much for watching.